Okay. All right, let's take a look. So normal distribution. Consider the normal distribution shown to the right and assume that P is a point of inflection of the curve. Complete parts A through C below. Find the mean of the distribution. Oh, it's going to be part A, part B, part C. All right, let me go back. Okay, so there's the three answers. So let me show you what's going on here. So that's called a bell curve for obvious reasons. It looks like a bell. It's called normal distribution. I'll explain more as we go. This is a normal distribution, a bell-shaped curve. And the middle of it, the very middle of the curve right here, is a little U kind of thing that looks like a weird U. It's a Greek M. It's called mu. I'm not going to quiz you on the names, but anyway. That's what it's called. It's a Greek letter called mu. It's a little U thing, whatever. You don't have to know the name. It's just a little Greek U. That's the middle. So that's what they're asking about in these two equations. It's the middle, however you want to call it. Mean, median, whatever. 83, 83. It's the middle. That's all you got to do on those parts. They're just saying, what's the middle? The middle's 83. And then they say, what's the standard deviation? Now, we've talked about standard deviation. We're going to see standard deviation in a different setting here. For now, let me keep it simple. The standard deviation is the jump from here to here. That's the standard deviation. How far from 83 to 98? The standard deviation equals 98 minus 83, which is what, 15. That's why the answer is 15. Standard deviation is the jump from the middle to the first line. I'll talk about lines and what I mean by that in a little bit. But for now, the standard deviation, as you see on the picture there, I'm drawing it for you. It's the jump. It's how far the jump is from the middle to the first line. And for now, just leave it at line. I'll explain lines in a little bit. Is that good to theirs? That's all they want in the first question. Is what's the middle? They ask it twice. And then what's the jump? What's the standard deviation? Remember what deviation is? Average distance from the middle. Standard amount off the middle. So it makes sense that the amount off the middle is the standard deviation. It's the jump from the middle. It's how far you are from average, from the middle, right? Okay, so question number 2. Consider the normal distribution to the right and assume that P and P prime are the 2 points of inflection on the curve. First off, they're saying, what's the median, the middle? It's just the middle. Whether you call it mean or median, whatever, it's the middle. How are we gonna find, how did I find that? How do we find that middle right there? It's going to be right in the middle of those two numbers. How do you do that? How do you find the middle of two numbers? You got a 66 and a 78 on your two exams. What's the middle? What's the average? Right? Average is the middle. How would you figure the average of those two scores? Add and divide by 2, right? That's how we find the middle of two things. We call it the average. We add them and divide by 2. That's right. So it's going to be 66 plus 78 divided by 2. 130, what's that? 144 divided by 2, 72. That's how I got the middle. So that middle must be 72. Good so far? Next question. What's the standard deviation? Now, what's standard deviation again? It's the jump from the middle to the first line. So it's how far from 72 to 78, right? That's the standard deviation. It's the jump. It's how much you deviate from the middle. So it's 78 minus 72. That's how I got the 6. Good. Now, third quartile. I need to give you a formula for that. Let me grab, I don't remember what it is. 16. There it is. Here it is. Yeah, so Q3 is mu plus 0.675 sigma. That sigma is your standard deviation is that weird little O thing with a squiggle at the top. That's called sigma. I'm not going to quiz you on the name, but just know that's standard deviation. It's a Greek symbol. Just know that stands for standard deviation. They use Greek symbols for this stuff. So just know those are the only two. No more to worry about. Just the M, that's kind of a funny looking M, that stands for middle. Middle. I mean, sort of. And then this is a Greek S, is what that is. It's a sigma. It's a lowercase sigma, Greek S. Doesn't look much like our S, but anyway, it's a Greek S, lowercase s. This is the uppercase S. You might have seen it on things. That's the uppercase Greek S, also called sigma. This is the lowercase Greek S. Stands for standard deviation. All right, anyway, so Q3 is this formula. You want to put that in your 3x5 card. We're going to use it a fair bit. So there's the formula. How do we do it? Q3 is mu. Do I know mu? What's mu? What's the middle? 72. Plus 0.675 sigma. What's sigma? Can you see it right here? Sigma is 6. It's the jump amount. It's the standard deviation. Oh, you can't see that very well, huh? Because that crazy thing's in the way there. Yeah. Put it up here. So Q3 is mu, which is 72, plus 0.675 sigma. Sigma is 6. So work that on your calculator. You're going to get 70, say round. This is round. So 76. Rounds off to 76. We good there? Everybody okay? And then there's one other part to this question. I don't want to do a whole new screen. They're also going to ask you on part D, they're going to say, give me Q1. The Q1 formula is almost exactly like the Q3 formula, except it has a minus instead of a plus. Remember Q1, first quartile? We're finding this stuff on a bell curve now. So there's the formula for Q1, the first quartile, into the first quarter of the data. It's always the middle back up 0.675 sigma. Subtract 0.675 sigma. So the middle is 72 minus 0.675 sigma. What's the sigma? 6. And that comes out, I have no idea. Somebody got that? Round it off. 68, 69, something like that. 68? Is that what it is? 68, thank you. 68. Yeah. That good? You all getting that? 68 for Q1? So you want to have the Q3 formula and the Q1 formula written on your 3x5 card. We will use those a fair bit. Q1 and Q3 on the normal bell curve. You want to have those. Good there. Like that. All right. I'll keep moving. Formula. Okay, let's take a look. So same formula. So they're talking about Q3 on this problem. So let's right away, without any further delay, write down the Q3 formula that I just gave you, which is what? Mu plus 0.675 sigma. Like that. Write that down. They're giving me the mu. They're giving me the Q3. 95.2. 81.7. Let me slow down there for a minute. Everybody see what I'm doing to that point? See how I just wrote down the same formula that we used on the last problem for Q3. You'll have that in your 3x5 card. You'll have that formula for Q3 and for Q1. And I'm doing that because they're giving me Q3, right? That's what made me think of it. They're giving me Q3, so I want to use the Q3 formula. I wrote it down. They're giving me the mu, 81.7. They're giving me the Q3, 95.2. The sigma is like an x. That's like an x. And this is an equation now. We can solve for the x. Solve for the little squiggle thing. Can you solve that equation using your calculator and stuff? What's the first step to get the little squiggle thing, the sigma alone? Subtract the 81.7, right? Yeah. Subtract 81.7, and you get, what is it, 13.5? Equals 0.675 sigma. What do you do now to get sigma alone? Divide by 0.675. Is it like 2? Or something close to 2? It's exactly 2, isn't it? Maybe I'm wrong. 20. Is it 20? 20? Exactly 20? So sigma is exactly 20 on that one. Solved a lot of little algebra equations today. Good on that. I think we can finish this section maybe. We'll see. 10 minutes. Is that okay if I move on? Thank you. Okay, so try that one. They're giving you the 47 and the 63. And they want you to find the mu, which is the middle, right? M, the mu stands for, it's a Greek M for middle. So it's like a U with a long left leg. You know, you can just make a U if you want, or an M or an X, whatever you want, as long as you know what they mean. They mean the one in the middle. So how do you find the middle then? What am I going to do? Yeah, find the average of the 47 and the 63, right? Just add them and divide by 2. 110 over 2, 55. So we get a 55, like that. That's the middle, just like we did before. And now, how do we find the sigma? The little squiggle with the O with the little squiggle on it. What do we do? If the middle is 55, what is the squiggle? Yeah, it's the jump from the middle to the first line. So it's the jump from the middle to the first line. That's your squiggle. That's your standard deviation. That stands for standard deviation. Average jump from the middle, in other words. So that'd be what? 63 minus 55. Is that 8? And there we go. That's the standard deviation on that one. I'll move on. Okay, so on this one, first thing is they want you to find, it's almost like the last one. They want you to find the middle. That's not a big deal. To find the middle, again, the mu is the middle. You just average the two numbers they're giving you. Add them up and divide by 2, and then you get the 78, right? Everybody good with that? That's the middle. Now, so that part's normal, no big surprise there. Now, the next part's going to be different. Normally, how do we find the sigma? Normally, I tell you, hey, it's just how far from the middle to the first line. Well, I've been being kind of casual because I didn't want to bring in too much information all at once. It's not always the first line. It's only the first line under certain circumstances. And so it's not going to be the first line this time. How do you know? It's because of what they say right there. I just kind of wrote over it. It's the 75% trick. So when you see 25% or 75%. You know what you should think about? Q1 or Q3. That's what you should think about. Because remember, 25% of the way through the ball game is the end of the first quarter. 75% is the end of the third quarter. So on this one in particular, you can't, when you see that 75%, you need to think, oh, wait a minute. They're wanting me to do one of those, right, I just gave you a Q1 formula and a Q3 formula. I've got to use one of those. How do I know? Because they're saying 75%. Okay, so now let's be really clear on exactly what we're going to do. So that's the first thing that should kind of grab your attention. Okay, now, if they're saying this all this shading is 75% of the data, that's what they're saying. All of that shading is 75% of the bell curve. Then how much is this white section? Got to be 25, right? Got to be the other 25, right? Which means this mark right here where the 73.25 is must be the end of the first quarter. And this must be the end of the third quarter, and this must be halftime in the middle. Those must be quarters. See how I determined that, right? Because if the blue is 75%, then the white must be the other 25. And that means, remember, like if you're starting the ball game here, and as you go along, right there, you're at the end of the first 25% of the ball game, first quarter. So 73.25 must equal Q1. Q1 must equal 73.25. So Q1 equals 73.25. And Q3 equals that. We could actually use either formula. It doesn't matter. I'll just do the Q1. So what's the what? What's the Q1 formula? Well, the Q1, remember, is mu. I gave you the formula a few minutes ago. Mu minus point, and you guys all have it memorized right now, right? I'm just kidding. You'll have it in 3x5 card. Mu minus 0.675 sigma. Right? Remember that? So, and you could use the Q3 formula just as well and use the 82.75. It'll work either way. I'll just do the Q1. Plug the 73.25 in for Q1. Mu, we already have mu, 78, minus 0.675 sigma. We can solve that equation for sigma like we did a minute ago. See how I came up with all that? What made me think about all that? 75%. When you see 75 or 25, you think, oh, Q1, Q3. They want me to do a Q1, Q3 thing. So you got to do it that way. Okay, so now can we solve this little equation here? How do we do it? How do we get sigma alone? Subtract 78. First off, gonzo. What happens on this left side? Is that minus 4.75, I think? Isn't that what that is? Yeah. Equals minus, careful, leave the minus in there. Don't lose that minus, right? Minus 0.675 sigma. Remember algebra, how you got to leave the signs in front of them? I always tell my algebra students, that's their baby. You take your baby with you wherever you go. That minus that was in front, that's his baby. Don't lose that. And then last step is to divide by the minus 0.675. Boom. And that'll be sigma, whatever that comes out to be. It's going to be positive, right? Because two negatives divided to be positive. Remember your signs. So, and that's the 7.04. Positive, because the two negatives make positive. Is that good on that? Everybody see? So again, the 75% made me think, oh, 75-25, that's Q1, Q3. So I identified Q1, I wrote the Q1 formula, and I knew Q1 was the 73.25. Plug it in, solve for sigma. Comes out 7.04 on your calculator. All right, let's. Okay, so let's see. So normal distribution curve. So I'm going to draw for you the standard normal curve. So So this one's real important. Get this down. These are the percentages on the standard normal curve. Okay, so what we have is we have the middle right here. And that's your mu. And then 3 lines to the right and 3 lines to the left. Got the middle, 3 lines to the right, 3 lines to the left. The percentages that go in here are 34 and 34 on the left and the right. 13.5, 13.5, 2.35, 2.35, and 0.15, 0.15. So it's symmetrical. Same percentages to the right, same to the left. Those are the percentages. Okay, and the numbers on the bottom, this is going to be mu plus 1 sigma. This is going to be the mu plus 2 sigmas. And this is mu plus 3 sigmas. Then on the left, it's going to be mu minus 1 sigma, mu minus 2 sigmas, and mu minus 3 sigmas, those lines. It's how many jumps right and left from the middle. Right 3, left 3. Is that making sense? We're just not making it, are we? All right, we're going to have to stop. I thought I could finish 16.1, but I cannot. So we didn't get 61 done. So just these ones will be due for homework. What's tomorrow? Thursday? Due for homework Thursday at class time. We're going to have to stop right there. Let me put a clicker quiz up for you.